So welcome everyone to this presentation on the future of multimodal search. I'm not sure where everyone came from, but it seems like from some initial questions that there are some architects, there's some product folks. So I think there is some technical background for some of the folks here. But if you don't have a technical background, that is totally fine. We have made this presentation such that everyone can learn something from this. And so yeah, let's get started. This is the future of multimodal search by Pinecone, and this is presented by me, Jacky Liang, and today is July 31st, 2024. Thanks for spending the last day of July with me and not enjoying the sun outside. So this is me, Jacky Liang. I am a senior developer advocate at Pinecone. And yeah, that's me. And the agenda today is pretty simple. We're gonna start with a live demo of Shop the Look, and we're gonna talk different use cases. And of course, we're gonna go into the tech, kind of give an overview, give it architecture, explanation, and we're gonna leave the Q&A till the end. But feel free to ask your questions in the Q&A section, and we're gonna answer all those questions at the end. We're gonna leave at least some time to answer your questions. And if you're not able to watch this whole webinar, we are going to have the recording done, and we're going to share all the relevant links, especially to the code, so you can, clone it, extend it, modify it to your own use cases and needs. And to give a really high level explanation of what Shop the Look is, this is an outfit inspiration sample app that works with text, images, and videos, and it's built using Pinecone, Google Vertex AI, and I got the royalty-free assets from Pexels, and it is hosted on Vercel as a serverless application. And to kind of give you a background on what a sample app is, I'm going to use this term quite a lot in this webinar. A sample app are fully customizable, ready to adapt foundations for your unique business use cases and assets. And what this means on a non-marketing level is you can take the code that I will share, and customize it. You can extend it, you can modify it, you can change it for your own use cases for not just this Shop the Look use case. You can do it for many other use cases, and I'll go into every single one of these. So don't worry if you miss out on something right now. And for this sample app for Shop the Look, we have it available as two different ways to install. One is the one-click demo mode, which installs in under 20 seconds. So you can get started with the front end and you can look at all the data that we have. And then we have a full production ready version where you can add your own data, you can modify all the code, including the backend and the front end. And we also bundle utility scripts for you to take all your assets, so images and videos, upload them to Google, get the embeddings, and then upsert all those embeddings to Pinecone. And we also are sharing a comprehensive README that lists all the steps, every single thing you need to set this up. And that takes about 30 minutes to set up. Let's get moving. All right, so I'm going to show a live demo of the Shop the Look. This is the first live demo that I've done for the community, so I'm really excited. And you can follow along by clicking this link or entering this, which is shopthelooksampleapp.pinecone.io. And I will share this. Oops, I guess I can't share this. I will type this into the chat so you can play along. Please let me know if you can't see this chat, pinecone.io. All right, just shared it at the chat. You can click into that. Let me double check if this works. Okay, it works. All right, sweet. Okay, so let's start with the live demo. And I'm going to change my screen real quick. I'm going to share and bring this up. All right, so let me refresh this. So again, the link is shopthelooksampleapp.pinecone.io. So all right, this is a first look at Shop the Look. And once you get to this website, you see a very simple search interface. This is not too different from something like Google search or Pinterest, or maybe your favorite e-commerce, such as Amazon. And let's get started. So right now is summer, right? Like it's height of summer. It's been pretty hot over the East Coast here. I'm going to search for some summer beach outfits for the weekend trip that I have. And I've gone to the beach a few times, so this is going to be really helpful. I'm going to click search. So, right after I click enter, I get results for summer beach outfits. I'm getting a beautiful gallery of shots. And however, these results aren't super relevant for me because I'm going to look for outfits for men. Summer beach outfit footbed. All right, this looks a lot more relevant for me. And again, you have a beautiful interface. As you can see, these are all images, and you're going to see something that's kind of unique from maybe other multimodal search demonstrations, and that is you get video as well. And so what's happening is I'm taking this search query. It's going to do all the background processing, and it's going to return not only the best matches for images, but also the best matches for video. And as you can see, this actually jumps to the portion where this application thinks is where this search term is most relevant. And again, this one is a different aspect. This starts at the beginning, so it thinks there's a match also in the beginning. And yeah, these results look pretty good. I think I might get some of these outfits. I really especially like this pineapple outfit. So let's look for something that's more different. I'm going to Cancun in November, so I'm going to look for some summer beach outfits for men and a tropical island. And as you can see, you can go very, very in depth with the search here. So I'm going to get some of these results. These all look great. I'm going to save some of these for my trip. So let me explain the UI really quick as well. As you can see, we are searching over 47,000 styles. And what this means is that I have about 47,000 assets that I've saved to my backend. And they include about 5,000 images, 5,000 videos and 42,000 images. And this is the search term, summer beach outfit. And you can see the similarity score here. And to really briefly explain what a similarity score is it quantifies how closely two vectors match. And it is calculated by comparing a query vector, which in this case, this is the query, and it's going to get vectorized using an embedding model. And it is then stored, and it's going to be compared against stored vectors using methods such as cosine similarity or Euclidean distances. And Shop the Look uses cosine similarity. And in the case of this, or actually for all cases of cosine similarity, it's going to be a range from 0 to 1. And higher score indicates greater similarity. And you can see that we actually sort this by the highest score. So here it starts out as 0.19, and it keeps going down to the 20 results, which then ends at a lower value. So this is sorted by top score. And again, higher score indicates greater similarity, and this allows Pinecone to rank and retrieve these most relevant results. All right, let's try some different searches. I want to look for maybe some fall jewelry for my fiance. And it's going to return some results that are very relevant to fall jewelry. So very warm colors, beautiful jewelry. Yeah, these are great results. And maybe I want to look into some engagement rings. I just got engaged recently, so I just want to see some more inspiration for engagement rings. Not that I'm going to engage again, but let's look for some engagement rings. All right, these are pretty good, but we can go actually more in depth. Let's look for some unique engagement rings. All right, these look pretty unique. I've never seen styles like this before. How about I'm my fiance loves sapphire, so let's look for some sapphire engagement rings. And yeah, these are definitely sapphire engagement rings. They are beautiful. Yeah, these are beautiful. Or maybe your birthstone is a ruby. So maybe you look for some engagement rings that use ruby. And yeah, these are beautiful. So you're going to see that there maybe are some results that don't match my search query. It's mostly because I don't actually have that much data in my backend. And so it's going to show lower relevancy for some of things that don't match. So this is a diamond and, more diamonds. And yeah, and I'm also a avid rock climber. So I'm going to look for some rock climbing outfits. How about this? Rock climbing outfit for men. And yeah, these are definitely rock climbing outfits for men. And I love these type of tank tops because it gives me better motion, right? And so let's move on next to, what people are really interested in, which is multimodality. And what does multimodality mean in this case? So not only can you search with text, you can also search with images. And I'm going to look for some similar outfits. So I'm going to simply drag this into Shop the Look, and it's going to look for similar outfits of this lady here. And yeah, this is extremely fast. And as you can see, similarity score, this is a really close match because this is the source image. And then these are similar outfits and similar poses by this lady here. And not only can you drag, you can also search through opening this modal. And I'm going to look for some outfits that look like this. So, this is a very popular style these days. and it's going to look for similar outfits that match this style. And as you can see, it actually also shows video. So there is image to video translation. And yeah, that looks pretty good. I'm going to save some of these outfits for later so I can buy it. And, let's do another example. So I'm looking for this cool shoe that looks melted, open. And again, it's going to return all these results that have really cool styles. All right, this looks good. And finally, the piece de resistance. I want to look for a video. Now, this is something that I think most people have not discovered before, have not been shown before, which is not only can we do text to image search, we're also going to be able to do video search. And this is something that I'm really excited about. And so let's say, for example, this is a use case. You're watching a movie and you see an outfit from someone that looks really good. So I'm gonna play this short clip. This man tying a tie. I think that's a pretty cool outfit. So what are we gonna do? I'm going to simply drag this over to Shop the Look. And what it's doing is it's going to upload this video. Takes a little time to upload. It's going to get the embeddings and it's going to perform a search on Pinecone. And the results are going to show up about any time now. Okay, great. So these are all the results for this video clip that just dragged in. Again, you're going to see multiple results that look similar. It's not similar. It's basically showing you the highest match this at this video, and it's going to skip to those matches. And this one is the beginning of the video. This one's about here, and a final shot, and it's going to find all these similar videos. And again, it also has images. So this is an image that someone took of this video shoot and it's going to find similar results. How about let's try something else. I recorded a video of myself, I really like this outfit, and I want to find similar styles or want some more recommendations. So I'm going to move this video again to Shop the Look. It is going to upload it and make sure that the video that you upload and the images is under 4.45 megabytes. That's a limitation of Vercel. And it's going to return to me again all these videos, all these images that match this outfit. And this one is all video, which is fine, but it works. And finally, let's do one more. Let's just do one more for the sake of it. I have a pair of pants I really like. These are what I wear to go bouldering, and I want to find similar outfits or similar pants. So I took a video of this. So again, you can imagine this as you grabbing your phone and taking a video of a pair of pants that you like, and you upload this to Shop the Look. And it's going to upload, it's going to get the embeddings, and it's going to search for this video. And okay, let's play some of these videos. So showing me a similar pair of pants, and it's showing me more kind of jogger type pants, and again includes videos and images. And so yeah, this is a live demo of Shop the Look and what it's capable of. And to reiterate, you can search through text, you can search through images through this, or you can drag videos in, and all these modalities work, and it's really performant and fast. And let's go back to my slides. So. Yeah, I really want to, make it known that Shop the Look isn't just a outfit recommendation service. It's actually more than that. This is a starting point, and it's a foundation of what you can do with this application. And that the code is all available now on GitHub and all the documentation. And I'll share these links at the end. So not only can you do, outfit recommendation, you can do retail visual search. So let's say a customer is in your store or they're doing online shopping. They can upload and take photos of something that they like, and they'll give you the links and the results back. You can do personalized marketing. So what this means is you can create targeted and personalized ad campaigns by understanding those user preferences, for example, e-commerce or social media, and you can target them through text, images, and videos. You can perform copyright protection. So, because this works across different modalities, you can easily detect copyright infringement by comparing those texts, those images that people have uploaded, images and videos. You can perform grocery delivery. So, for example, maybe I saw a meal that I really like on TikTok. I can take a photo of that meal, and I want to cook this for my fiance. I can upload this video, and it automatically creates a grocery delivery for me for all the ingredients that the system detects. You can do content moderation. It can automatically detect and filter out inappropriate content that you define. And of course, you can also do fraud detection. So you can analyze transaction descriptions, user behavior patterns, and images of documents to identify potential fraud. So again, Shop the Look is just the beginning. This is not what it can all do. It could do way more than that. And that's why we have open sourced this code so you can build on top of it. So I will really briefly explain what Pinecone is as well and why it's being used to build Shop the Look. So Pinecone is a AI company that allows developers to ship better generative AI apps faster. And we also want people to build knowledgeable AI. And in Shop the Look, Pinecone acts as the database that we store all the vector embeddings for text and images and videos. And Pinecone serverless is a decoupled architecture that delivers up to 50% cost savings for any scale with vectors in a low-cost blob storage. We also have an industry-first clustering-based algorithm that delivers low latency, delivering always fresh data at a high recall at a low cost for any scale. And of course, serverless means that we are a fully managed service that delivers a seamless user experience for near infinite hassle-free scaling. And you can get started right now with Pinecone with our starter tier, which can do everything that Shop the Look can do, but way more. So basically, you can run Shop the Look on Pinecone for free. And I also want to really quickly explain what vector embeddings are for maybe our not so technical folks. On a really high level, vector embeddings are a way to represent complex data like words, images, videos, audio, or concepts as a list of numbers known as vectors. And why people use them is that because it captures and represents meaning in a format that that machines can efficiently process, enabling tasks like similarity search, clustering, and machine learning. And in this case, it's doing outfit recommendation. And it's done by, vector embeddings are generated by neural networks known as embedding models that are trained on a large data set to convert input data into meaningful vector representations. And how Shop the Look is run is it's using something by Google, Google's Vertex AI called the Multi-Modal embedding model. And they basically took millions to billions of text, images, and videos and condensing that into a neural network that generates these vector representations that are unified across text, images, and videos. And really quickly, I also want to explain the type of embeddings and models. Most traditionally, you may have used this, for use cases like RAG, which is retrieval augmented generation, we're using text embeddings and generated by text embedding models. So what this does is it converts words or sentences into numerical representations. And the most common models here are E5, text embedding Ada 002 by OpenAI, BERT by Google. And then, of course, we are seeing some, lot of discovery into image models. These are models that convert images to vectors, and CLIP, MetaClip, ResNet are the most common ones these days. And this is starting to become more cutting edge and more commonly adopted for multimodal use cases. There are also models for video. And what this essentially does in the background is it captures frames from videos, and it also transcribes audio to text and converts these into numerical representations. And the most common or best ones we've seen so far at Pinecone is 12 Labs and Mixpeak. And of course, for this demonstration, we are talking about multimodal embeddings. So the type of embeddings are multiple. There's multiple embeddings. Oh, sorry. As you can see on the diagram on the left, and you can use text, you can use JPEGs, you can use MP4s, and the two biggest ones, and honestly the two only ones right now are Google Vertex AI's multimodal embedding model and Meta's image bind. And in Shop the Look, we are using Google Cloud Vertex AI's multimodal embedding model. It is a mouthful. And how multimodal embeddings work is, again, I've kind of explained this, but I'll quickly go over this. Multimodal embeddings represent multiple types of data. So text, images, videos, audio, and it converts this data into a unified vector space. So text, images, and videos are all across one space. And the advantages of a unified vector representation is that, again, it's unified. You don't have to use multiple models that have mismatched dimensions that don't work together. Instead, it's all unified across one dimension, 1408 dimension. and it enables cross-modal search and comparison. And honestly, it's generally easier and cheaper to implement for multimodal search than a traditional search, for Google that requires manual human tagging of labels and keywords and metadata, which is time-consuming, laborious, and expensive because we're relying on people. People are expensive part of any system. However, it's not all rainbows and sunshine. There are challenges when it comes to multimodal embedding models. And the biggest one is that it's a very new field of research that are compared to text embeddings. And there's not a lot of multimodal embeddings available right now. There's only two that I know of that is, you can actually implement, which is Google's, which is what we use, and Meta's, which is ImageBind. And there's very little community and vendor support. So when I was developing this, I actually had to do a lot of debugging and discovery and troubleshooting by myself. And I went through this so that you don't have to go through this. And I also have a troubleshooting section and limitation sections in my documentation in case you run into the issues that I ran into. And I discovered how to fix those so that you don't have to waste your time. And of course, there's not a lot of examples or tutorials or guides available. So again, with this webinar and with this project, I hope to distill what I learned and what I ran into so that you don't have to. And again, I've already talked about this. There is these two models, and the Google one supports text, images, and videos. It's also the most advanced and capable, and I found it personally to be very easy to use, but it does have some limitations. So images are downsampled to a square format of 512 to 512 pixels. It doesn't currently support audio or audio in videos. It does take a bit of work to set up. Like you have to set up your Google Cloud account. So you have to download the SDK and install that. You have to set up all the permissions. You have to create, you have to enable different APIs. So there is a bit of setup, and it is hosted, which for some people that is a benefit, but also for some a hosted infrastructure is a downside as well. And then also there is the Meta Image Bind. It does support more formats. So it does support text, images, audio, video, IMU, depth data, and heat map data. Supports a lot of stuff. However, it is said by Meta that this is not production ready. And also, I don't see much active development on it anywhere anymore, so it does seem a little abandoned. Doesn't seem like there was a lot of resources poured into this. It was more like a tech demo than something production ready like what Google released. It was also very difficult to install and set up, and I have not been able to set it up personally, but if you do, feel free to contact me and tell me how you did it. It's also self-hosted. So for some, again, this is a benefit, but for some, this is a downside. And let's dive into the technical architecture and overview and how I built this program, how I built Shop the Look. It's honestly a pretty simple architecture. And so it is separated into the front end, which is this piece here. It is also the back end, which is this piece. And we also include these processing scripts that take your data, processes them, uploads them, and then generates the embeddings for them. And it's saved to vector database. And I'm going to go in depth into each of these pieces. So don't worry if you can't see this very clearly. Sorry, let me just take a sip of water. Thank you. Okay, so let's dive into the front end. And the front end is powered by Next.js, Tailwind CSS, and custom React components that I created. And again, all this code is open source. You're free to build on top of it, modify it, change it to your own. You don't even have to call it Shop the Look. You can call it, I don't know, Shop the Fit or Cop the Fit. And this front end powers a user interface and search experience for Shop the Look. So what this does is it takes user query requests, which you've seen in my live demo. People are typing stuff into the search box, or you're dragging images, dragging videos, and it makes these calls to the backend of our Python backend. So basically what this does is it takes user requests, takes images, takes videos, and sends all this data to the backend. And it and then it helps with processes the API response, which gets sent back by our backend, and then serves images and videos using the public Google Cloud Storage URLs. Let's dive into the backend. So the backend is where the primary logic of Shop the Look happens. And so yeah, this app is a JavaScript front end and a Python backend. And so what it does is it takes when someone sends a request or the front end sends a request to the backend API, it first gets processed in the index.python file, and then it gets routed to either text, image, or video, and it retrieves these. Then it takes these takes the data and sends it to our embedding service, which then retrieves the unified embeddings from Google Vertex AI's multimodal embedding model. And then what it does is it performs a cosine similarity search against our Pinecone index over here, and it returns results. And as I've said before, a similarity score gets returned back to the front end values from 0.0000 to 1.21, and this gets returned back to the back end and then propagated up to the front end. And within the API response, it has the similarity score and all the associated metadata. So this includes things like the file name, the file path, the file URL, file type, segment information, which is for videos only, which is what powers the timestamp feature, and more. And I won't go too in depth here. And finally, we also provide with you the processing scripts that you need to bring your own data. And so right now, Shop the Look has a data set of royalty images from pexels.com, and it's 47,000 images and videos. And I've used these processing scripts that processes images and videos. So it basically takes a folder of images and videos, it uploads them to Google Cloud Storage and has to be stored in a public bucket. Then it generates these embeddings and upserts them to the vector database. So everything that gets stored, all the images and videos that get stored in the Google Cloud Storage now serves as assets in the front end. So it's actually a very lightweight app because every image and every video is stored off the actual app itself. So it's very lightweight and very performant. And since this is a production ready app, you're probably very curious about how much something like this costs. And in a previous slide, I talked about how this is an easier and faster and cheaper way to do image and video search compared to old school ways of doing metadata tagging. And so I want to explain to you the cost breakdown. The total cost for me to set up Shop the Look was $73. And the majority of the costs came from the Google multimodal embedding model. So $10 was used for 42,000 images, and $50 were used for getting embeddings for 5,000 videos. And of course, this cost is going to differ for you depending on the dimension of your video, the length, and the segments that you use. And when I mean segments, I mean what is the interval between getting a segment for each video. And I think for Google, it goes from every 8 seconds to every 30 seconds. And the lower segment interval, the higher the cost for you. And Google Cloud Storage to store all this stuff and to serve as assets was under $4, and Pinecone serverless was essentially $0, because even though the cost here says $8 for the starter tier, we include a bunch of goodies for you. So it's basically $0 for you. And it's going to be $0 for a long, long time for 47,000 images. And you could probably include 47,000 images and videos and would still be $0. So Pinecone is extremely performant and also extremely affordable for you to build your production ready apps. And let's really briefly go through installation. And so again, I've talked about in the beginning that there are two ways to install Shop the Look. There is the demo deployment, and then there is the full deployment. And I've included a very simple kind of flowchart for you to decide which installation that you want to do. If you don't have your images and videos and you just want to test it out really quickly, just use a demo deployment. It's super simple. You can actually open up your command line right now and type in npx create Pinecone app and define the template as Shop the Look. And in 10 to 20 seconds, you will have Shop the Look ready, running as a React front end that you can play around with using our data. But however, this is for testing only. And the reason why is you don't get to bring your data for your own images and data. You don't get to extend this to your own use. This is only for you to test and demo, and we don't recommend this for production use cases. However, we also have available a full deployment, so you can deploy a fully customizable Shop the Look. And what this does is you can bring your own data. You can include your own images, your own videos. You can upgrade the UI. You can update the UI, customize it to your own business use case. So, for example, the use cases I talked about before, such as fraud detection or ad recommendations, you can build that. And you can also make updates to the backend to suit your own use case. However, this is a more involved setup, and so it requires setting up Pinecone serverless. So you have to bring your own API keys for Pinecone. You have to set up Google Cloud Vertex AI. So that entails having a Google Cloud account, although they do offer I think $300 free credits. Again, that's more than enough for our use case here. You have to set up Google Cloud Storage, and you have to bring your own data. So you have to make sure that you have your own images and videos. So you have to process those using our processing scripts. But the benefit here is that it's adaptable to your use cases, such as retail visual search, personalized marketing, grocery delivery, and more. And that's what's so powerful about Pinecone sample apps, because we've open sourced everything. We have a stellar documentation that covers every single step that you need to set this up. And we also have troubleshooting, and we tell you what the limitations are for the technical limitations are for this application. And so there are, again, service limitations, and these are limitations for Shop the Look based on our hosting provider. And so let me cover them real quick. And there are two primary parts of limitations. So there is the front-end limitations for our services and back-end service limitation. So for images and videos that you upload for Shop the Look, which is the user interface, you can't upload images or videos that are larger than 4.5 megabytes. And that is due to Vercel and its front-end limitations of not allowing people to upload 4.5 megabytes. And so if it's images, we do offer compression, so it should be compressed, and we will tell you if the image is too big and or it can't be compressed. However, for video, we can't do client-side compression, so please make sure that your video is a smaller dimension or it's lower frame rate, so that's under 4.5 megabytes. And in the back end, there are some limitations as well. So with the way that Python serverless works for Vercel, which is our hosting provider, you can only route requests to the API route, and you can modify a bit of this in the next config.js rewrites, but in the end, all requests are mapped to /API. Also, some users may encounter some authentication issues with Google Cloud SDK, which affects mostly the video embedding retrieval. But I offered a workaround and offered a solution that I got from the Google Cloud team. And hopefully it works out for you or you don't run into this issue. Also, for Google Vertex AI, the multimodal embedding model crops the images to a 512 to 512 pixel dimension. So it's a square image. So if your image is a panorama or something that's too wide, make note that it's only going to look at the middle section, the square section. So if you are getting results that aren't accurate, that's probably why. And also for images and videos, it works best when the background is white, basically a undistracting background, black, white, any solid color. But I think white, from my experience, was what works the best. And also, if you can crop the image or video to look for the exact object that you're looking for. So for example, if I'm looking for this shirt, you might want to crop such that you only see the black shirt and not including the face, because it can be confused. The model itself might get confused by too many objects or too distracting of a background. So just something to keep note of. And finally, Vercel's Python backend is a fairly new product. So Vercel's known for their JavaScript frontend and backend, so Node backend. They recently released Python serverless, which allows you to run a Python backend to the API route, but it does have a limitation of not being able to exceed 250 megabytes in size. So you shouldn't include image or video assets to your Python backend app, and you shouldn't have libraries that are greater than 250 megabyte in size. So just something to keep note of. Again, all this stuff is written in detail in the documentation that I will share at the end of this, and you don't need to take notes. I have everything for you, so don't worry. I went through all these limitations so that you don't have to run into the same things that I did. And so kind of to conclude this webinar, and we'll get to the questions really quickly, this is Shop the Look. And we want to really reiterate that Shop the Look is just the beginning of what you can build with our sample app. You can get the code now. I'll share the links into the chat and as an email at the end. But you can get the code now at Shop the Look GitHub repo. And what you can do is, again, you can create retail visual search. You can create personalized marketing. You can do copyright protection. You can do grocery delivery. You can do content moderation, and you can do fraud detection and anything that you can think of that includes text, images, and videos. So these are just some ideas. And I'm really excited to see what all of you build. And please email me or, find me on LinkedIn or find me on Twitter and share with me, what you build, because I'm really curious what all of you build on top of Shop the Look. And I appreciate you all coming. And so we're ready to take questions. Okay, I'm going to open up the chat. Sorry, Q&A. Okay. I got the first question. So what is similarity search? So again, similarity search, I'm going to go back to the slide where I explain this. So yeah, let's get to this question. So again, if you need to ask a question, go into the Q&A section and ask them, and I'll cover every single one. So similarity search, a score in this case is it quantifies how closely two vectors match. And so the first vector is the input vector. So this is the input text, input image, and input video. And it goes to the Google embedding service, which captures these vectors and compares it against our Pinecone backend, which has 47,000 vectors of all our images and videos. And it calculates by comparing a query vector to the stored vectors using methods like cosine similarity or Euclidean distance. And again, Shop the Look uses cosine similarity. And the higher score indicates a greater similarity, so better the match, and allows Pinecone to rank and then retrieve these most relevant results. And we retrieve the top 20 results, and you can change this yourself at the back end. Okay. Okay, seems to me the results are very relevant. Why the similarity score is only 0.1x? That's a really good question. So from my own testing, there are different kind of ways that text and images and videos differ. So for example, if you have an image that is very similar to another image, the scores tend to be very high. So like 0.9, so almost like a 90% match. However, for text, I'm not exactly sure how the nitty-gritty works for this model because they didn't release a white paper for me to read. But I tend to notice that for text, even if the match is very close, the score does seem to be lower than what you expect. But because we are ranking it based on the highest level to the highest score to lowest score, it doesn't really matter. And you can actually obfuscate this from the user, or you can do re-ranking on your own. So kind of to summarize what your question is, it doesn't really matter that the fact that there are some results that are lower in terms of the value because we are returning the results based on the highest value to the lowest value. What is the best benchmark to consider for the cosine similarity score? I understand it depends on the business context, but are there any general rules of thumb? Um, I'm not sure exactly what you mean by best benchmark to consider. If I understand correctly, you might be asking how should you sort, right? And if that is your question, you should just sort by the highest value to the lowest value. And you can also return more results. So in this case of Shop the Look, we are returning 20 results. You can return 5, 10, 50, anything you want. I'm sorry if that was not your question. So because I didn't fully understand what benchmark meant in this case. How is the backend we are finding cosine similarity between text and images? The backend is completely the same. So it is returning results based on the unified embedding. So the embeddings that I'm getting for text, images, and videos are all in the same embedding space. And so the scoring is similar. And so in the way that it's finding cosine similarity, it is the same. How does similarity search work? Again, this is I see that there's a lot of questions on how similarity search works. I may have already answered this, but it is strictly performing a cosine similarity search, and this is defined at the index creation. So when I'm creating the Pinecone index, I'm defining that it is a cosine to use a cosine similarity algorithm, and I define that it is 1408 dimensions, so 1408 dimensions, which is how many dimensions this unified embedding has, and it does all the rest with some simple lines of code that I can that is shown in the backend. How to align same meanings across different modals. I'm not exactly sure what you mean by aligning the same meanings across different modals. If you want to re-ask this question by what you mean, feel free to rewrite it again. Okay. If you already have embedding vectors from OpenAI, Google, etc., is there a way to convert to Pinecone embedding vectors? I don't want to have to send the raw data again to do the Pinecone search. I want to just send OpenAI, Google, other embedding vectors and get the answer. So if I'm understanding your question correctly, you might have different embedding models that you've already generated embeddings for. So for example, you're using text embedding Ada 002 for OpenAI. Unfortunately, with the way vector embedding dimensions work, we can't currently attribute different embedding types and embedding models to other embedding models. So you would have to regenerate all your embeddings for this use case. So you will use the Google embedding model to generate the text, image, and video embeddings and re-upsert them to Pinecone. So you can't reuse the vectors at this current technological point. Can you please talk about if these multimodal embedding models are called at application layer or in Pinecone? Can it combine two embedding models if user posts both if the user posts both text and images? So this is a really good question. The answer is that if you generate the text, image, and video embeddings from the Google Vertex AI multimodal embedding model, then yes, you can mix these modalities together. That's why it's one unified embedding model and creating unified vectors. Sorry, the question was, and you had another question, which is the first question. Um, sorry, I'm trying to refind it. Let's see. Okay, found it. So can you please talk about if these multimodal embedding models are called at application layer? It is called at the backend layer. So if you want to see how this works, what you do is you clone our code and you go to the backend, which is under the API folder, and you look at the text, image, and video Python files, and that'll explain kind of how we do the vector retrieval and comparison. How do you choose, evaluate which embedding model to use? So really good question. In the case of multimodal embeddings, there's only two models available. So the Google one and Meta's ImageBind. I was unable to get ImageBind working because you have to host it yourself, and I ran into some dependency issues, out-of-date dependencies, and so I wasn't able to get this working. However, Google made it quite easy for me to set this up because it was hosted on Google Cloud. I did have to do some setup with enabling APIs, setting up permissions, creating a service account so that I get an API key that I could use. But overall, it was quite easy to set up. So I recommend Google's multimodal embedding model. It also is being actively developed. So I do see updates with this model. So I recommend that. And if there are new models coming out, I would definitely be very, excited to try it out. Also curious how NeuroDB engines perform in this space. Thank you. I don't think I've experimented with NeuroDB engines before, so I don't want to give you a wrong answer. The question, so yeah, the answer is I don't know. Can you clarify the running cost per day or per month? This is a really good question. So when it comes to Google Cloud, there is EC2 is it EC2? Yeah, EC2 costs involved. And there are also costs involved with retrieving the Google Cloud Storage image files and with Pinecone. However, the retrieval for both Google Cloud Storage as well as for Pinecone is extremely low. So we're talking about like probably cents to under dollars per day. If you have a lot of users for retrieving embeddings and using this app, then the cost might be higher. But this is talking about like maybe 10,000 embeddings per day or like per month. That might be a little higher, but from my costs that I'm looking at right now, I think this cost maybe like $20, $30 to run, including all the services. So it is quite performant and also quite cost effective. And if you have questions about cost, feel free to email me. I can talk to you more about that. How do you store all the embeddings for all the images, video, and assets? So this is a two-part question. One, I'm storing all the unified embeddings into Pinecone, and there are 47,000 embeddings in my Pinecone indexed. As for the images and videos, I've stored these in Google Cloud Storage as blobs, and I'm calling them at the front end level when I get the API response, which then includes a public URL to the asset itself. So I'm actually rendering the asset on the front end through calling Google Cloud Storage public URL. So it's a very lightweight application because I'm not storing any images or assets as part of my application. It's simply calling them. The cost you indicate to us is per month. So Esma, great question. The cost that I shared was the initial setup. So the majority of the cost from what I anticipate is from the setup part. And why it's a setup part is because this is processing the images and videos and getting the embeddings and storing it into Pinecone. So as in the cost breakdown that I shared, let me go back to the cost breakdown. The majority of the costs here were related to getting the images, which were, so 42,000 images were $10 and 5,000 videos were $50. And the majority of the cost was in getting the video embeddings because it has so many frames and we use a lower segment for better accuracy. So this is for the initial setup. I anticipate that if your usage is not overly high and you have maybe a few hundred users using this, I expect this to be under like $20, $30 per month. So it's still cheaper than I think manually tagging images, which is how traditional image and video search does through humans. Once a user uploads a video, image, or text, it first goes to Google Vertex, gets embedded, then it does a similarly search over all the embeddings or assets. This might be causing latency. Is there a better way to do this? Really good question. So I think any way that you can lower latency. Is going to improve your user experience. And I can tell you that for both text and image search, the latency is extremely low. I'm talking about like under maybe 500 milliseconds. The reason why video takes a bit of time is because I not only have to upload the video, which is a few megabytes, it is then being processed by Google as multimodal embedding service, which is where it takes more of the time because it has to take, for example, for a 120-second long video, it's taking a segment from each 8 seconds, which is the segmentation setting that I have. And then it's calculating these embeddings, returning 1408 dimensions, and it's upserting that to Pinecone. So the majority of latency here is happening at the embedding level. And you have to go through the embedding model in order to retrieve the embedding. So there's no skipping through this. So, however, if you're able to find ways to lower the latency, or maybe one day Google improves the latency for the video in particular, then that's going to cause a better latency. But I can tell you that text and image search is really fast. However, for video, depending on your segment kind of setting and how long it is, it's going to take a little longer. And also it depends on your upload speed as well. Uh, let's see. How can I differentiate the model used for embedding, LLM, and multimodal, or can we use the same model for embedding as well as LLM or multimodal model? How can I differentiate the model used for embedding LLM? I'm not sure I fully understand your question, but to kind of reiterate, we are simply using Vertex AI's multimodal embedding model, which takes any modality, so text, image, and video, and converting it into one unified vector embedding space. And so you don't really have to think about the modality as long as it is a supported modal. So for example, in images, it supports JPEG, BMP, PNG, JPEG. So those are the supported formats. And for video, it supports numerous formats like MP4, AVI, etc. And so as long as it's a supported format, it just has to go through one endpoint, which is the API endpoint. And so I'm sorry if that doesn't answer your question, but hopefully that helps. Hello, when you retrieve the items, if I'm not wrong, you retrieve all the items based on the ranking, so you show infinite list of items to the user. However, what happens if I only want to show the specific item that are related to the query or image? Is there a good way to decide when to stop showing items like a threshold? So that's a really good question. Right now, the way that we retrieve the top results is through the top K setting for Pinecone. So top K just means the top K, where K is a specific integer. And so top 20 is what I retrieve. And of course, in the backend, you can do some re-ranking. And that's actually a really cool thing that you could do. So for example, I want to only get the videos. Then I would first get maybe the top 20 and figure out which are videos. And then I get some more results until I get 20 videos. And so you can do some re-ranking through that. Or maybe I only want to get images. So I do a re-ranking on the top 20 images where all the results then get condensed into top 20. And so you can do some stuff in the backend, and it's all dependent on the metadata. So you can do re-ranking through metadata. So I hope that answers your question. As for something that's like overly detailed, like, I only want a shirt that's black colored like this, that might be a little harder, but we can discuss that if you want to reach out to me. So this can be used with Vercel only. Very good question. So I actually think this doesn't have to be Vercel only. There are some Vercel settings that I've configured, such as next.config.js, but you can actually probably run this on DigitalOcean, on your own EC2 instance. But there would be I think you'll probably have to change a little bit of settings, such as the fact that I call environment variables using Vercel's own environment variable structure. But if you are able to change that to some other cloud service specific environment variables, then you can run this in a different cloud. And that's a really good question, actually. And I can explore a bit of that on what you might need to change if you want to run this on Amazon, on Google Cloud, or DigitalOcean, Heroku, etc. But yeah, I can imagine that you have to change the environment variables. And I would think that's probably the biggest piece. And I can investigate this a bit more afterwards. But yeah, great question. How was your experience of Google's multimodal LLMs in terms of latency and quality? So the quality is pretty good. And as I explained before, you do have to make sure that the images and videos that you are searching for, so in the search query, that the background is not distracting. And especially if you're looking for a specific item, so for example, like I'm looking for a pair of glasses like this, it's best that you crop the image that you're searching to the specific item that you're looking for. So don't crop for the face because it might return results of who I look like, as opposed to the way that you can, as opposed to the glasses itself. So this is actually a cool machine learning problem, which is called segmentation. You want to segment the thing or the object that you're looking for. And Meta actually just released a library called Segment Anything 2, which really easily lets you segment different objects. So you can just click a shirt and it would just crop just the shirt. And you can use this to create better results. So in terms of quality, make sure that's not distracting and try to crop to the specific item that you're looking for. In terms of latency, text and images are really fast. Video does have some latency. So that is something to take note of. But I think for any video search on any service that you have right now, such as on TikTok or YouTube, there's latency for that too. So I think it's actually not that different from any service that you have currently. What is the difference between your search model and semantic search? Great question. So semantic search from what is traditionally known as semantic search is that it is purely text only. And so you're using a embedding model that is created specifically for text input and text output. So I think some of the more common ones are like E5 or whatnot. And it takes a sentence or takes words or takes tokens of text and then finds similar representations in vector space for similar text and sentences. And so I think I actually have not worked with semantic search before because I just joined Pinecone, but from my understanding, semantic search is mostly for text. But meanwhile, for this model, it is performing a search across not just text, which is a semantic meaning, but also in images and videos. Okay. What would it take to weight results for an e-commerce retailer? For example, if the retailer wants certain SKUs to show up higher in the results. Really good question. I think the most simplest way is to do re-ranking after you get your top K results. So what this means is you perform a similarity search on Pinecone, you get the top 20 results. So for each result, there is going to be not only a score, which is how I rank right now, but also metadata. So in your metadata, you might have things like the category of what the item is. So maybe it's a shirt or a pair of pants. You might have the ID of the item. You might have other metadata information. And so what you can do is you can re-rank the results dependent on the ID, the category, or maybe there's a sale going on and bring those results to the top. That's what re-ranking is. And we actually have some really great articles written by our other DevRel folks that talks about re-ranking. And you can use re-ranking to basically change the order of the results based on what you want the results to look like. Does Python only use cosine similarity? No, it uses other similarity algorithms as well. So we have cosine, we have Euclidean, and I'm sure there are other ones that escape the top of my head, but I can share articles with you later that talk about what similarity are available. And this is done at the index creation phase. How will you monitor and optimize the performance of the multimodal search system? Great question. Again, I actually do latency. I check I actually track the latency of everything from when you enter a search term to how long it takes from getting the embeddings and then doing the Pinecone search in the background. So Verticel allows me to perform logging like that using a timing function. And so that's how I kind of monitor the performance. In terms of the optimization, I would say that the majority of the latency is happening at the embedding level. And so unfortunately, there's not much I can do as a Pinecone employee. But as Google makes further improvements to this model, I'm sure that latency is something that they are thinking very hardly about. But again, text and image search is extremely fast because we're only getting one vector back for text and one vector back for images. The reason why videos take so long is because it's depending on how many segments that you're getting per 120-second long video, you're getting multiple embeddings back. So Google's embedding side has to take a look at each cut and then perform the embedding on each interval. So again, depending on how many intervals that you have, the longer that would take. Can you describe why to use Pinecone versus other services, Chroma, Vertex AI, Vector Search? Great question. So Pinecone is extremely performant. You can check the benchmarks yourself. It's extremely cheap. So for example, you can run Shop the Look across maybe for the next like 12 months, 24 months for free, extremely affordable, and it's extremely fast. again, the latency that I'm getting from this application is not really on the Pinecone end. It's more on videos at the video embedding end. And so, any improvements that we would want is probably on the embedding level. However, when we retrieve and upsert Pinecone vectors, it's extremely fast. And not only that, we have a incredible developer experience. So, one thing that we want to achieve using these sample apps is that you can simply take this application, it's open sourced, it's licensed in a way that's friendly to businesses, and you can simply build on top of it. So far, we're not really seeing other vector database vendors that is providing such comprehensive sample apps, starter apps that you can build on top of with such great licenses. And so, really, the reason that you would choose Pinecone is that we're fast, we're affordable, we have a very generous starter tier that you can, start right now. And of course, our developer experience is incredible. We have great documentation. We have a great community that is available on Discord, available on the forums that you can ask questions. We are also very active as developer advocates, and and honestly, everyone on the team is extremely active in answering questions. We're highly available, and we have great samples available for you in the form of notebooks, sample apps, other types of apps. So this is why you would use Pinecone, because we deeply care about the developer experience, and we don't just talk about it. We actually show it by action by having these things available for you to just clone and build on top of. Cosine simulator has been the go-to search algorithm for years, mainly starting out in NLP apps. Is there a better simulator search algorithm for multimodal? So that is a really good question, and that this might be beyond my technical expertise at the moment. The recommendation that Google recommends us to use is cosine simulatory search, so that's why we're using that. And I'm not sure they recommend anything else yet, but as they make improvements to the model, maybe there are changes here. Check out Vector IO for easy migration of your existing vector data into Pinecone. Thank you so much. So yeah, seems like a tool where you can migrate your existing vector database data into Pinecone. Thank you. How to align a picture contains a beach with the English word beach. How to align a picture contains both a beach with the English word beach. I'm not exactly sure what you mean by this. Are you saying that, let's say the image itself has the word beach in it, can you search for the word beach? The answer is yes, you actually can. And it works for videos as well. So let's say you have a bunch of images or videos that has certain words in it, like physical words that show up in the asset itself. You can simply write a word of whatever that word is. So let's say I have an image of a cat that also says cat on top, and then like maybe the type of cat that it is, like an orange cat. You can literally search word of orange cat or word of cat or text of cat. So you can actually search for text inside. And this is where this fraud detection ad recommendation can really come in, because you can actually search for text within the assets itself. Really powerful ability. Do you have an opinion on multimodal embeddings versus embedding a text description of image and video? This is a great question. And this actually goes back to cost, right? Because traditionally for multimodal search, how companies like Google, Facebook, Pinterest do it is there's metadata attached, textual metadata attached to each image or video that is a description of what that image might be or what that video might be. And in order to get these descriptions, you either use humans or you use a model that previously describes that text or that image or video, and the accuracy is generally low, and it might not take into things like context. So and it's all dependent on how granular those descriptions might be. But as everyone says, a picture is worth more than 1,000 words, right? So having those native embeddings of images and videos is superior, in my opinion, towards just a textual description of an image or a textual description of a video. And also, when it comes to video, it is something that spans across thousands of images. So you can't describe every single frame, right? So in the end, the answer is there is a difference between the way image and video search is traditionally done versus how this is done. This is, I think, cheaper because you don't need to rely on humans. All you have to do is throw the images into this embedding model and save it, and then you get all these embeddings, which has some sort of native understanding of the image and video itself. So it understands context, it understands color, etc. We have a few more questions, and it is running out of time, but I'll keep answering them. But if you need to go, feel free to go. Is also use custom or fine-tune embedding models. From what I understand, I think image bind does offer fine tuning. I haven't really explored it yet, but for the Google embedding model, there is no fine tuning. What you get is what you see is what you get. So this is obviously the topic of closed source versus open source. But I actually don't think the weights are available for the meta image bind and body model. So I didn't explore that too deep, but if you want to look into it and you have some really cool findings, feel free to share with me. Can you store data like text metadata alongside the embeddings in Pinecone, or does it strictly hold embeddings? Great question. Pinecone not only does it hold the actual score and the embeddings, sorry, Pinecone not only does it store the text the numeric embeddings itself, it holds metadata, and you can throw in a bunch of metadata. So, for example, in my case, I stored the URL, the type of data that it is, so image, video, text. It stores the public URL that points to the Google Cloud Storage, and you can put any metadata that you can. There is a bit of a size, the maximum size in terms of what the metadata is. I think it is 50 kilobytes, but don't quote me on that. The documentation for Pinecone will have that information on what the max metadata size is. But for the majority of the use cases, that metadata size is more than enough for you to store pretty much any text that you need. And that is pretty much how RAG, retrieval augmented generation, is done. Okay. The fashion is interesting, but I'm also getting cool results when searching home design like maximalist room. Is this because fashion and interior design are related? Hi, Jocelyn. Do you mean that you're also getting results on Shop the Look for interior design? The reason why you're getting maybe interior design results is because according to the embedding model, yes, interior design and fashion is probably related because the assets I'm using from pexels.com are very high quality. So what this means is that not only is it showing high quality outfits in my results, in the background it also has high quality interior design. So really doesn't matter what data that you throw into it, as long as the thing understands the context of the image and the video itself, it's going to show you the relevant results. And this is where the benefit of a multimodal embedding comes from, because if you're simply using a text description of an image or video, it won't capture that interior design background stuff unless you're telling the labeler to also describe that. But I think if it's an outfit use case, that using metadata to attribute to what something is, it's only gonna look at the clothing and not the background. Okay. I'm going to answer maybe like one or two more questions. Have you considered logging user acceptance rates from the search, i.e. thumbs up, thumbs down, logging that as an input to help improve the app over time? That is a great suggestion. And I think that that is a great feature request. And I really encourage you to make that feature request as an issue on the ShopLook GitHub. And finally, is it reversible? Can I send a snapshot of my fridge contents that have list ingredients for me to make a recipe? Currently, this does not offer so what you're describing is you're asking the application to describe in text what it is that is shown in image and video. Currently, this is not supported by Google Multimodal embeddings. You would actually need a different model for description or narration in this case. So it doesn't offer that at the moment. Okay, that's all the questions. I hope you, okay, so I'm going to also share with you guys at the final all the links. So we will share these slides, and at the end there's a Shop the Look app, which is a link to the app. It's going to link you to the GitHub documentation. So this contains all the code, the documentation, all the troubleshooting, every single step you need to build your own. And I'm linked to Google Vertex AI's multimodal embedding model and some explainers on vector embeddings and what Pinecone serverless is. Really appreciate all the questions.